Hello, in this video I'll be talking about standard form of a linear equation, which is ax plus by equals c. The benefits of the standard form of a linear equation is we can use them to find the x and y intercepts very quickly and then draw the line through those. And so once you practice this method, you'll be able to graph equations that are in standard form very quickly. So let's figure out first what we're talking about when we talk about x and y intercepts. So I'm just going to point a few out to you here. Let's start with y. So here's the y-axis, and all of the points on this y-axis could be y-intercepts. We're looking for a place where the line that we're going to graph crosses the y-axis, and that's called a y-intercept. All these points on the y-axis all have something in common. Let's see if you can figure it out as I write down a few of them. What do all these points have in common? Okay, well, if you thought, well, they all have a 0 in the front, then that's true. So every ordered pair that touches the y-axis, even the ones down here, all have a 0 as an x value. So in order for a line to touch the y-axis, x has to be equal to 0 at that point. And so if we want to find the y-intercept of an equation in standard form, or in any form for that matter, all we need to do is substitute 0 in for x and then figure out what y would have to be. So if we look at this equation here, 2x plus 3y equals 12, to figure out what the y-intercept is, we're just going to plug in a 0 where x is. So I'll just plug in 0 here. So 2 times 0 is 0, and plus 3y equals 12. So we know that y is going to have to be equal to 4. So right away I know that 0, 4 is going to be the y-intercept. So I'm going to erase all those now that we understand what we're talking about. So 0, 4 is the y-intercept, made a big dot there. To find the x-intercept, it's very similar, but first let's talk quickly about some points on the x-axis here. What do you think is in common between every pair of points, every pair of coordinates for something on the x-axis? I'll just write down a few of them. Here's one, -9, 0. Here's another one, -5, 0. Here's another one, 3, 0. So what do these all have in common? If you say, well, the second number is always 0, then you'd be correct. So the y value of every point on this line has to be equal to 0. So that's another way to quickly find the x-intercept. So let me erase that now. So to find the x-intercept, we just plug in 0 for y. So 2x plus 3 times, I'll put it in the same color this time. I think we get the idea. So 2x equals 12, and we know that x has to equal 6. So at 6, 0, we have the x-intercept. And then to draw the line there, all we have to do is connect it, and we know what the equation, what the graph looks like. Connect these two dots, and we're good to go. So that's how you can graph quickly using standard form. Find out what the intercepts were for this equation without graphing it. I would just need to think about what has to be true about the intercepts. So if I wanted to know what the y-intercept is, I know that x has to be 0. So 4y equals 24, so y must equal 6. So now I know that the y-intercept is equal to 6, which means the point that it's at is at 0, 6. To find the x-intercept, that's when the y value is 0. So I plug in 0 for y. And then 3x equals 24, so x must equal 8. So I know the x-intercept equals 8. which means the point is 8, 0. So without graphing, I can quickly figure out the y-intercept and the x-intercept of this linear graph. Now, if I want to get a graph of an equation, if I'm given this equation in standard form, all I'm going to do is put 0 in for x. So 0 plus 5 times something equals 20. So I know one of the points is going to be 0, 4, right? Because 5 times 4 equals 20. To find the other point, I'm going to plug in a 0 for y. And I know that 2 times 10 equals 20. So now I figured 2 points out really quickly in my head. Excuse me, I can make the points right there. I can graph my line in a matter of seconds. So that's how easy it is to use standard form for graphing. We haven't yet talked about graphing horizontal and vertical lines, so I'm going to quickly go over that. It's pretty simple. When we see something like x equals -2, what we used to do is we just would put it on a number line. We got 0, we got -2, and we put a dot there. The only time we usually use a coordinate grid is when there's two variables. However, if we're being asked to graph an equation like x equals -2 on a coordinate grid, it's actually very simple. Just pick all points where x is equal to -2. For instance, -2, 0, -2, 2, -2, 1, -2, 6. Every point you can think of that has a -2 as x, and what you'll come up with is just a line that touches all those -2 points. And so that's, whoops, just move that over on accident. So that is the graph of x equals -2. It's just a vertical line on x equals -2. Now the graph of y equals 3, you could probably guess based on what we just showed you on the last one, but pick all points where the y value is 3. So 0, 3, 2, 3, 4, 3, 1, 3, 1.5, 3, -6, 3, you get the idea. And what you'll come up with is that it's a horizontal line at y equals 3. So it's pretty simple to graph horizontal and vertical lines. Sometimes we are given an equation in a different form. For instance, this one. Take a guess before I tell you. What form is this in? This equation is in slope-intercept form, and we need to write it in standard form. Now remember, I wrote this on the first page. Standard form is ax plus by equals c. What I didn't say is that a, b, and c are going to be integers. Okay, so what you can see from this form is that x and y have to be on the same side, and a and b and c are going to be integers. Now this plus sign doesn't have to be plus, it could be minus. Okay, so let's see how we can do that. The first thing we're going to need to do is get rid of this fraction. Easiest way to get rid of a fraction is multiply everything, not just the fraction. Some of you guys are still making this mistake. Multiply every single term by the denominator. So I'll show that by multiplying by 3, and then I'm going to multiply this whole side by 3. So I get 3y equals 3 divided by 3. So is 1. So we have -2x, and then 3 times 1, so -3. So now we are halfway there. We got rid of all the fractions. Now we just need to get x and y on the same side. It's pretty simple. Every time you're going to either add or subtract. So in this case, we're going to add 2x to both sides. And we're going to end up with, let's put the x term first. So we're going to end up with 2x plus 3y equals -3. And that's it. So standard form just means that you have the x and y on the same side and that there's no fractions. So for my last example, I'm going to show a real-world application of figuring out an equation for this and graphing it. So let's read this. A media download store sells songs for $1 each and movies for $12 each. You have $60 to spend. Write and graph an equation that describes the items that you can purchase. What are 3 combinations of numbers of songs and movies you can purchase? Okay, before we get to the question, let's start with the equation and the graph. And we can do the equation first here. So we have songs that sell for $1, movies for $12. Let me highlight this important info. Songs for $1, movies for $12, and $60 to spend. But we don't know how many of each. So I'm going to make up some variables here. S is going to represent number of songs that we can buy for $1. And M is going to equal number of movies that we're going to buy. So if songs cost $1, if we multiply 1 times S, that's going to give us the amount of money we spend on songs. We could just write S there, but I want to show that we have that dollar in there. Now, we're also going to use our money to buy movies, and movies cost $12. So we're going to multiply the number of movies times 12. So this term really means the amount of money we spend on songs, and this term is the amount of money we spend on movies. And the amount of money we spend on songs plus the amount of money we spend on movies is going to equal how much money we were allowed to spend on songs and movies. So here's our equation. As you can see, it's in standard form. It'll be real easy to graph and find the intercepts. Now I need to label these, so we can call this M for movies, and we can call this one S for songs. So we're at 0 here. Let's change it around so it's in alphabetical order here, because that's how I did my graph, right? I got M and S. So if I have 0 movies, I can buy 60 songs. And if I buy 0 songs, I can buy 5 movies. So this only needs to go up to 5. Here, so let's spread it out a little bit. So here's 1 movie, 2, 3, 4, 2 movies, 3 movies, 4 movies, and 5 movies. Here we go. And for songs, I need to get all the way up to 60. So that's going to be not quite as much room there. So I'm going to do, let's see, can I go by 5s maybe? We'll go by 5. So 5, 10, so 10, 20, 30, 40, 50, and 60. Okay, so we're not going to get all the way up to the top, but that's okay. We spread it out a little bit. So we're going to make our mark at 0, 60, and that's right here. And then 5, 0, and that's right here. And then we just need to get a line from here all the way to here. And we've got our graph. So now that I've finished that, I'm going to go back and reread the problem here, make sure everything looks good. Sells songs for $1 each, so I can get 60. Movies for 12, I can get 5. Write an equation, write and graph an equation. So here's my equation, one of those, and I graphed it. Now, what are 3 combinations of songs and movies I can purchase? Well, here's 2 combinations. 60 songs, 0 movies, 0 songs, 5 movies. And then if we can find some intersecting grid lines, like looks like, there we go. I can get 2 movies and 35 songs. And that looks like pretty much it. It's not really intersecting there. It's not intersecting there. So let's see if this makes sense in our equation. 2, 35. So if we say 24, so 2 times 12 is 24, plus 35 times 1, so 35 plus 24 is 59. So I think what you'll find graphically is it's tough to get an exact amount graphically, but what it will do is get you really close to the answer. So we were off by $1 there, and that's okay because it might have been this line is like just a tad too high or something like that.